Hello, hello, hello. Welcome to this video on condensing and expanding logarithms. So we're going to go both ways. Let's first talk about condensing logarithms. So logs have this really cool property where we can take a whole string of logarithms. In this case, you can see I have 4 log terms, and we can condense them using a really simple pattern. I think that you can actually figure it out just by watching me do it. So see if you can figure out what this pattern is. I can condense all 4 logs into a single log expression like this. So putting them all into one big mama log, I get and then on the top, my last one is going to be, can you figure it out? Yeah, it's h to the power of g. So what the heck did I do there? Well, it's actually a very simple pattern, and you probably caught on. The first thing I did was all the numbers in front of the log being multiplied to the log, right? A times log b, c times log d, right? These are all being multiplied in front. All of those numbers became exponents, a, c, e, and g. So the first rule is called the power rule. So if you want to write it down, the power rule says that a log b becomes log of b to the power of a. So the number in front, you cross it out, and you move it to the exponent. So that's the first rule. The other thing you probably noticed is that besides these getting crossed out and becoming exponents, is that my b to the a went on top, so did h to the g. Do you know what they have in common? They're both positives in front. So notice that my g log h term was a positive term, so was a log b. So if it's a positive term, it'll go on top into the numerator. On the other hand, d to the c had a negative in front of it. So it's the sign in front that tells you what happens with d to the c. It's going to go into the denominator because it had a negative in front. Same with e log f, or f to the power of e. It has a negative in front, meaning that this guy's going to go into the denominator. So the other thing that you're learning now is called the product and the quotient rule, which says, so let's start with the product rule. It says that log of a plus log of b becomes log of a times b. And then the quotient rule, quotient meaning dividing, says log of a minus log of b becomes log of a divided by b. Notice again that the guy with the negative in front of it, so this would be the log b, b would go to the denominator. And then my a belongs to a positive log, therefore a is in the numerator. So on the right side of our notes, you can see the 3 rules. But in this first example, you can see how they all mesh together at the same time. So let's try an example. So let's see. Oh, there are no examples. Well, that's kind of weird. Okay, I'll make up an example then. Never mind. So write down expand. Or wait, no, condense. We're condensing. So let's say I have 1/3 log 8 minus 2 log x plus log of x minus 1. And the question says to condense. Well, noticing that everything is separated by minus and plus signs, I know I can condense these into one big mama log. That's what I like to call it. Now my first step is to cross out the numbers in front. So that 1/3 becomes 8 to the 1/3. That 2 becomes the x squared. This last log has no number in front, so there's nothing to do. Next, I'm going to draw big parentheses and a division, right, a fraction symbol. Now, anything that's positive in front is going to go in the numerator. Anything that's negative in front is going to go into the denominator. So check it out. This 8 to the 1/3, well, 8 to the 1/3 we know really is just the cubed root of 8. That's 2. So I'm going to put a 2 in the, look at the sign in front of it, not the sign after it. That 2 is going to go in the numerator, just like that. Let's see where x squared goes. X squared is going to go into the, yeah, look at the sign in front. The sign in front is a negative, so x squared is going to go in the denominator. Just like that, super easy. Now the x minus 1 will go into the, yeah, the numerator because the positive in front. So x minus 1. Now you might be wondering, well, what do I do with the 2 and the x minus 1? Always, always, always these things multiply together. Therefore we need parentheses here. So that means that our final answer is log of 2 parentheses x minus 1 all over x squared, or log of 2x minus 2 all over x squared. Let's do one more example. This time you try figuring it out yourself. Let's try 3 log a, or actually let's try negative 3 log a plus a half log of x plus 5 plus 4 log y. Okay, try it yourself. Pause the video. So assuming you've tried it yourself and pause the video, first thing we'll do is cross out the numbers in front, make them exponents. Now, with this 3, you might want to, I can understand if you had crossed out and put a negative 3, but I want you to avoid that. Instead, just focus on the number. So that 3 becomes a cubed, that 1/2 becomes actually a square root, and that 4 becomes a y to the 4th. Now we can deal with the signs. The signs tell us where the terms after them go. So I'm writing my 1 big mama log, and a cubed is going to be in the denominator. Square root of x plus 5 in the numerator because of the plus sign, and then y to the 4th also in the numerator. Make sure that you're multiplying them, not adding them. That would be incorrect. So you need to be multiplying them. Now, if you were like, wait a second, I could have crossed out, I could have put a negative 3. Yeah, notice that a to the negative 3 would have had a end up in the denominator anyway, because it becomes 1 over a cubed. But to avoid confusion, because it does get tricky sometimes, I would always, always, always just do the number and then follow the sign in front. Okay, now for the second half of this video, we're going to expand our logarithm. So expanding is just going backwards. Let's see if I can convince you that it's also super duper easy. Check this out. So in this example, I have 5e to the 4th times square root of x plus 1 all over the cubed root of y. So our first step is to count the factors. Factors meaning the numbers that multiply. How many things are being multiplied together? So I definitely have 2 factors on top and 1 factor on the bottom, but actually I have 3 factors on top. Because notice that 5 is also being multiplied with e to the 4th. So even a number all by itself like that counts as a factor. So I have 1, 2, 3, 4 factors. Now my next step is to rewrite this so that all the exponents are visible as numbers. So this would be 5 to the 1. Every factor gets an exponent, e to the 4th. And that guy becomes x plus 1 to the 1/2, because I need to rewrite that radical as an exponent. Then on the bottom I get the cubed root of y, which is really y to the 1/3. Okay, so now watch, I'm going to expand this. Now the number of factors you have, 1, 2, 3, 4, is the number of logs that you're going to write down. So my first log, see if you can catch on to the pattern, it's going to be 1 natural log of 5. Do you see why I did that? I did the backwards power rule. I took the number in front that would be the exponent, that is the exponent, and I moved the exponent back to the number in front. Next, I'm going to put plus for natural log of e. Do you know why I put a plus sign? It's because it's coming from the top, so these are all going to be adding. The only thing that's going to get subtracted is the term that's in the denominator. So it is following the same rules. Plus 4 ln e. See if you can do the last two terms yourself. Pause the video. Hope you paused it. And you should have gotten a plus 1/2 in the front, moving the power to the front. Natural log of x plus 1, and then a minus 1/3. Moving the power to the front gives you a 1/3 here, but it's minus because it's coming from the denominator, natural log of y. Now you'd be super close, but we're not quite done. You should know this rule, which is that the natural log of e is always just equal to 1. Why? Because the natural log of e, well, the invisible base here is e. And the question is, e to what power gives me e? The answer is 1. Right? If I were to rewrite this like that, I'd say, oh, e to the x is e, therefore x has to be 1. This whole thing equals 1. That's a rule you just need to know. Natural log of e is always 1. Also, you should know that the log of 1 is always 0. So if we know that natural log of e is just 1, then our final answer, is natural log 5 plus 4 times 1, which is just 4, plus a half natural log x plus 1 minus 1/3 ln y. Cool. Hope that was helpful.